Good morning. Today we are going to see about the modes of heat transfer, which is one of the small concept in thermal physics in IGCSE. Now I'll quickly go through the definitions. I think most of you might know the definitions and the theory behind it. But then let's see what are the similarities and differences between the three. The differences is what you need to be aware of, because sometimes when you're framing the answers like theory answers, you may include certain terms which might be incorrect or inappropriate to use for that particular mode of heat transfer that you should be aware of. So I'll be focusing mainly on those theory answers that you have to be careful about and not lose any marks there, all right? Now, the three main modes of heat transfers are, as you know, conduction, convection, and radiation. Now, what's the definition, or how do we describe conduction? Is when you have a solid, actually we relate conduction with solids. The reason being, conduction is the transfer of heat due to the vibration of the molecules. Now that's a key term here, vibration of the molecules, right? Here, the molecules in a solid, we all know they are uniformly arranged, or they have a regular pattern of arrangements. Now, if there is a disturbance in one of the molecule, say at one end, what happens to the molecule? That will gain energy, it will start to vibrate faster, and that is transferred to the neighboring molecules. How? So you have all these molecules regularly arranged, or they have equidistant, they are equidistant from each other. Then if there is a disturbance caused to this molecule, it might be vibrating this way or this way, disturbing the neighboring molecules, right? Now we have the vibrations transfer, so this will transfer to the next one, then the next one, and so on. So such as you have, but then what is the key here? Will this molecule move from this point to the other point? That doesn't happen. The molecules stay where they are. Only thing is that they only transfer the heat energy that they gain, all right? So here the key term is vibration. When they vibrate faster or vibrate with more energy, that energy is transferred to the neighboring molecules, but as such, the molecule is not displaced. It stays in the main position of the molecule is same as it is. Now coming to convection, how is it different? Convection happens in fluids. Now fluids is the general term used to refer liquids and gases. Now, what's the main difference between the molecular arrangement in solids and liquids and gases? Solids, you have, as we discussed earlier, fixed pattern, but then in liquid, you have the molecules have the freedom to move around in a fixed volume of space, right? If the liquid is occupying up till here, the molecules can move about anywhere inside that volume of space. How about air? Yes, air has got, there is no limitation, it can move anywhere, we know about it, all right. Now what happens to these molecules when you are providing heat energy at one point? Now here also the molecules closer to this heat energy, they might be getting more energy. Those molecules will vibrate faster or move with greater speed, and the result of this greater speed or greater energy, what happens? They'll be hitting each other with more force, same as before. But then unlike here, since the molecules have freedom to move, there is more space, they can push themselves apart. So if I draw an enlarged image, you have the molecules separated. So you have, earlier they were closer to each other. Because of this gain in energy, they will tend to push each one of them apart. So you have the space between the molecules greater than before, or greater than the rest of the liquid. Do you agree? Here the molecules may all have same equidistant from each other, but here in the space where it has absorbed the heat energy, the molecules are further apart. Now when they are further apart, what can you say about its density? Density here and density here, if you compare these two, the molecules inside or where it has gained the kinetic energy, there you will have the molecules to have less density. They are less dense, am I right? Because they are spaced out. The intermolecular space is greater compared to the other liquid. Hence, they are further apart and are less dense. Now, this is the key term here. This area where it receives heat energy, it will be less energy. So that liquid is also hot, right? So if you compare in a liquid, what's the principle of flotation? What the object that is lighter will come to the surface and float, heavier object will sink. But here it is only one object, but comparatively the density in one area is less than the density in the other part of the liquid. So what happens is this liquid will rise, correct? So the space occupied by this will be now taken over by the other part of the liquid, which are heavier or denser, and they are cold as well, right? So what's the difference here? The molecules are in their fixed position, they only transfer the energy, but here the molecules are actually moving. See the terms? Here it's only vibration, here the molecules can move. So why do they move? Because they have gained energy, they are less dense. Keep this sentence alone, please concentrate. They are less dense, they are lighter, they are hot, they rise up. Okay, so what happens to the heavier, denser, cold molecules or cold liquid? That will sink. Okay, so this is rising and that's sinking. So you have some circulation of these molecules, which we call that as convection current. Okay, this movement of cold and hot liquid, or the same effect can happen in gas. So this effect that's happening in fluid is called convection current. Clear? That's how the heat is transferred through in a liquid or in a gas. Hot air rising, we have seen that, the cold breeze, you might have learned it in geography also. So that's due to these exchange of heat energy through the molecular movement. I hope it's clear. Now coming to radiation, it's these two, some way you can relate, but then radiation is where you cannot describe it with the molecules because they themselves have their energy. Radiation, infrared radiation actually, in other words, you have that as part of the electromagnetic spectrum. So what's the speciality of electromagnetic spectrum? They have their own energy, electricity and electric and magnetic field oscillate in perpendicular directions. So they do not require a material medium to transfer the energy because they carry their own energy. Hence, they can travel through vacuum. Clear? So now we'll see the differences, or as I mentioned earlier, what would the common mistake that students make is they write here in conduction, if they are asked to explain conduction, they say the molecules gain energy and move. If you use the term move here, it's inappropriate. The molecules do not move in conduction. They only vibrate in their main position. That's a key term for conduction. Now here there are many key terms that I've written, but then what you need to remember is just this. When they gain heat energy, they hit each other with more force. Intermolecular space decreases. Intermolecular space means what? The space between the molecules increases. So the intermolecular space increases. Hence, they are less dense compared to the rest of the liquid. They rise up. The heavier, colder or denser liquid will sink, or air will sink. That's the circulation of heat energy. Radiation, it does not require a material medium. So what's the main difference between these two and radiation? These two require a material medium to transfer heat. Radiation do not require a material medium. I hope the definitions and the concepts are clear. We'll just see it in a real life example. Now, if you want to trap the heat from a liquid, so what do we normally do? Say you have a plastic cup. Plastic is an insulator. So if you leave it open, it's a hot liquid, right? If you leave it open, what happens eventually? It will get colder. Now, if you want to reduce the heat transfer, what do we usually do? We just cover it with a lid. Okay. So when you cover it with a lid, what type of heat transfer are you preventing? Now here you've got air above the liquid, so you're trapping the hot air. So the hot air is not allowed to move out. If the lid wasn't there, the hot air will rise and the cold air will sink. Again, they will absorb the heat from the liquid. the convection, the transfer of heat will happen through convection current. So you're preventing that. Now this, I said it's made of plastic. So plastic is what type of material? It's an insulator again. So it will not allow the heat transfer. So what type of heat transfer are you preventing? You're preventing conduction here. Okay. So through the sides you're preventing conduction. By covering it with a liquid, you're preventing convection. Now, are you preventing radiation? No, because radiation can transfer through. Now, which is the best type of containers that could retain the heat longer? Of course, it's a thermo cup or thermo glass or flask, whatever. Now, what do they in addition have there? Now, if imagine this to be a thermo flask, they have like a double insulation. So this might be attached to the cap. So forget about the lid and all. Now here you have vacuum. So why do they have vacuum there? Just to make sure that the heat energy will not be transferred through the sides, and even if there is air, the side also there could be convection current happening if the heat has escaped through it. Now here I said it is plastic, but in some of the thermos, they have steel inside, so the steel can absorb the heat as well. So if you have vacuum here, is there any possibility of the heat to escape to this area? No, because there is no molecule present. So conduction and convection are prevented here. But do we prevent radiation? No, radiation can still pass through. Now how do we prevent radiation? Radiation can leave the flask, but this also is reduced by another mechanism, which is inside of this double insulation, that is here, you have, it is a polished silver surface. It is polished. So what is the difference? What will that have on radiation? We can have the radiation reflected back. We all know that if it's a smooth silvery surface, you can have most of the radiation reflected back. Hence, even if the radiation leaves from the liquid, obviously it will be reflected back into the container by having this silver surface. In olden days, they used to have glass, covering, but that keeps breaking. But now you have, like a smooth silver surface to reflect the heat. So you have to identify like what type of the material, or is it possible for the heat to escape, or what modes of heat transfer is happening. First identify that and see if it is possible for the heat to escape or not, and frame your answers accordingly. Alright, I hope this would have given you some understanding about the modes of heat transfer and to frame the answers. See you in another video. Bye.